Good morning, and today we will be starting a new chapter. It's a chapter that I think you'll like, Chapter 7, the Assembler. At this point, once we start using the assembler, we are not going to need um, to do all sorts of calculations that we had to do before. And I think what we'll do is we'll just jump right into it. The first thing that you'll notice, what I have here, this is just a text processor, not a word processor, a text processor that I'm going to be using to write a very simple program to show you how things go. And I'm going to start writing some things, and I guess I'll explain them as I go on over there. Um, this is the first line in it, and it's a period ORIG. I'll explain what the period ORIG means in a second, but basically what this is saying is that the code that I'm about to type in, I want it to be loaded into the LC3 at location 3000. Now I'm going to imagine I want to do something very simple here. I just want to load some registers with a number, and we'll do this as follows. Maybe I should just type it in and things will be clear. Just give me a moment to type this all in, and I will explain in a moment. Oops, that needs a period. And here is our first program using an assembler. So first of all, let me distinguish between a couple of things here. You'll notice that some things in here have periods in front of them. I see this fill has a period, fill has a period. I have a thing here that says block word 1, end, and you'll notice up here that there's an ORIG. Okay, so anything that begins with a period okay, that's what's called a compiler directive. Okay, and what that means is I'm telling the compiler to do something, but it's not generating executable code. My executable code is right over here. And we've been sort of using these abbreviations previously, so this shouldn't look too weird to you. Let's talk about these compiler directives first. This is telling the compiler, okay, that when I load this program, I want to load it at memory location 3000. Okay. This over here, fill, this is the LC3 assembler way of declaring a variable. I'm declaring a variable called 1, and I'm saying, okay, I want it to have the value 1. In other words, what the directive period fill does is it allocates one word, and it actually initializes that word to the value 1. Likewise, down here, I have declared a variable 2. And again, I have said to the compiler, please allocate one word for me by fill, and I'm saying initialize it to the value 2. Now, 3 is a little bit different, and again, that is a variable. But over here, I'm saying block word 1. And what I'm saying to the LC3 here is I'm saying declare me one word, okay, designated by this word 1, and initialize it to 0. And you can see if you come up here and look at the program, okay, I'm adding two numbers together in a register, and then I want to store it someplace. I'm going to store it at 3. If I came over here and I made this a 2, what that would do is that would actually allocate 2 consecutive words, and they would all have zeros in it. If I came over here and I said 5, that would allocate 5 words. Let me just give you another example here. If I came in here now and I did 4, and I said make this fill, and I don't know, I said hex 0067. I want to show you a few things here. Since I'm saying to organize this at location 3000, this line right here would be at line 3000. And I'm going to do one more thing here. I'm going to show you how you can stick comments in here. And you stick comments in here, actually I don't recall. I think it's with a semicolon. I've got my book over here. Yes, it is. Okay, so this is at location 3000. And this statement over here, this is at location 3001. This is at location 3002. This is at location 3003. This is at location 3004. Let me put the X in the front. Okay, so this would actually be at location hex 3005. This would be at hex 3006. Now this, I'm allocating 5 words. So there's going to be 3007, 3008, 3009, 3000A, 3000B, 3000C. So you can see that I have done over here, that's 1, 2, 3, 4, 5. Whoops, one too many. And I'm going to say that these are all filled with hex 1, 2, 3, 4. So if this went all the way up to 3000B, we're going to see over here that this is hex 3000C. Okay, and first of all, so let's remember a couple of things here. Everything with a semicolon, anything after that is a comment. So the way that you type in instructions into the assembler is pretty simple. You can have a label, okay, and then you have your operand and you have your opcode, your opcode and operands, okay, and then there is, okay, so anything that's enclosed in brackets like that is optional. I don't have to put them in there, okay, but you can see what's going on here now. Remember what we had to do before. Over here, we're saying LD into R01, and here's 1. Remember what we had to do last time when we were just actually, when we were putting in machine code, we had to calculate the offset. Well, let's see. If I'm executing 3000, the PC's at 3001, so I'd have to go +1, +2, +3, +4. So what I'd have to do up here when I was putting in the actual machine code for this, I had to specify that, oh, the value that I'm looking for is really 4 spaces ahead of here. And you may remember we had to stick that into a 9-bit number. We no longer have to do that anymore. We now have, we can use these labels, which make things really easy. So now let me show you what I'm going to do with this. What I'm going to do is I'm going to come over here and I am going to copy this whole thing. Right like that. Okay, I'm not going to copy this down here. I'm going to come over here and I'm going to say edit, and I'm going to do a copy. And now what I'm going to do is I'm going to come over here. Remember, this is our online simulator right here. And I am going to come over here and I see this thing assemble. I want to get rid of that because that's the one that I was practicing on before. But now I'm going to come over here and I'm going to say edit, and I'm going to paste. And here is the program that I typed in. I guess the cutting and pasting did a little weird stuff with the formatting. Let's see if I can clean this up a little bit so it's a little more readable. And I'm going to get rid of this comment here because the assembler will not be happy with that. I'll just come over here and say start at. Okay, so first of all, let's look at this thing here. It starts at location 3000. We hope it does. We'll see what happens. And I'm saying load into R0 the value at 1. Well, that is just the number 1. Load into R1 the value at 2. That's the value 2. I'm saying add those two together and stick the result into R2. And then I'm saying star R2 at 3, which over here, notice I gave it a block word 5. I didn't need to do that. I only need to give it a block word 1. But I wanted to demonstrate to you how this thing block word works. Okay, and here's a variable here that we're not using. And again, this is just for demonstration purposes. Okay, so we understand what this does, the period ORIG. That's telling the compiler where I want to load the program. These, the .fill and the .block word, we're asking the compiler to allocate some space. In one case, we're saying allocate one word and actually assign it a value. In another case, we're saying allocate a certain number of words and make them all 0. And here's a very important one right over here, period end. Okay, the compiler wants that. It has to know when it's stopping work, and that's how we tell it that. And what I'm going to do is I'm going to come over here and I'm going to click on the Assemble button. And it says, oh no, you have an error in your assembly code at line number 9. Let's see, where is line number 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'll bet it wants this to be a hex, like that, hex 5. So I'll do that. And now I've got to get back down to the assembler code. Let me close this up and hit the assembler button again, which is down here. Okay, notice that it's got a hex 5. Let's see if it likes that now. And look at that. It says awesome, which we all knew. Okay, and now I'm going to say take this program and load it into the simulator. So let's come over here and look at the simulator now. And you can see, look at this. My program did load in at location 3000. And look at this. This was how we wrote it previously. Okay, here's the machine code, but now we can write it this way. And by the way, look at what happens when I come down here. I don't know why there's a label over there. We'll go back and look at a second. Here's my label 1 with the number 1 in it, and that's at location 5. This is at location 6. Here's location 7. And by the way, look at what happened, because remember I did a block word 5. So 3, here's 1, 2, 3, 4, 5 memory locations that have all been initialized to 0. And here's my variable 4. Okay. I'm not quite sure why there's a label 1 there. Let me go back and look at my code. That's very interesting. I have no explanation for that. But what I'm going to do here now is I'm going to come over here to this thing halt, and I'm going to set a breakpoint here. Okay, and I'm going to come over here, and I'm going to clear all my registers. Okay, and now what I'm going to say is run, and of course it should run to halt, and I say run. Okay, and a couple of things I want you to note. We loaded R0 with 1, so there's the value 1 in it. We loaded R1 with the value 2. There's the answer there. We did an add R2 of R0 and R1, so I added these two together, and I got R3. Or, I'm sorry, R2 has the value 3. And then here I said store it at 3, And if I come over to 3, right over here, it does not appear to have stored it. What is the issue? I don't know. Let's try this all again. I'm resetting all my registers. I'm going to single step through this thing. So I do step, step, okay, step, there's that. And now over here, I should be storing R2 at 3. And it doesn't appear to be doing that. Let's find out why. Let's come over here. My first guess, let's change this to fill. And let's just make this 0. And now let's assemble it again. It said awesome, and I'm going to load it into the simulator. And now when I load it into the simulator, notice that now I've got 3 and 4. I'm going to clear all of these things and reset them. I'm going to come over here. Oh, is there a breakpoint set there? And there's a breakpoint there. Maybe that's why it wasn't doing it. Ah, I get it. And I say run. Oh, and look at that. Now notice over here there was a 3. I had a breakpoint set there. That was the problem. Okay, so notice what it did is I added 1 and 2, and then over here I stored them into R2, and then over here I said store it at 3, and there it is over there. So that is my first assembler program. Very cool. Okay, let's try another program now. Here was our first program. Why don't we do another one here? And we've written this one before in class. Let's multiply 2 numbers. So let's come down here. We'll make some notes to ourselves as we do this. I'm going to create a couple of variables. I'll have mult1 and I'll have mult2. And I want to come over here and I want product to get mult1 times mult2. Okay, so these are going to be things that these will be labels, and I'll declare them after my halt statement. So in other words, there's going to be halt, and I'll come over here, and I will have mult1, and I'll put some number in there, and I'll say fill, I don't know, let's make it 6, and I'm going to come over here, and I'll have mult2, and why don't we make that 7, and I'm going to come over here and I'll have product, and we're going to get this to work this time. I'm going to make that a block word 1. That's where we'll be storing the answer, and we'll have an end here. So I need to come over here. We'll start this program at 3000. And I think what I will do is I will load these various numbers into some registers. So I'll load into R0, mult1, and I'm going to load into R1, mult2. Okay, and remember what the idea is here. I can pick either one of these. I'm assuming these are positive numbers. I'm going to keep adding one of these into a register, and I'll keep subtracting 1 from this until it gets to 0. So I'm going to come over here, and I'm going to say and here's going to be something different. R2 is where we're going to save our answers. And here is how I specify that I'm using the immediate mode. I use the #0. So this is saying let's AND R2 with a 0 and stick the answer into R0. So I'm going to come over here, and here is going to be my main loop. I'm basically going to say add to R2. I'm going to say R2 comma R1, and then I'm going to say add to, so that's R1, so I'm going to subtract 1 from R0. So I'm going to say add to R0 comma R0 comma pound minus 1. Okay, so this is the cool part right here. Again, this is subtracting 1 from R0. Here I keep on adding R1 to R2, and as long as R0 is positive, I want to branch and do it again. So I'm going to say branch positive, and I'm going to say iterate. That works. Now I can do a couple of things here depending. I could come over here and put the word iterate, or I could actually put it up here. As long as it's on a blank line, it's going to be associated with this instruction right over here. So you can see what I have here. This doesn't look good up here. I said and R2, somehow a character disappeared like that. Okay, I can even do this if you prefer. The blank lines don't mean anything to the assembler. So you can see if I want to, I can nicely delineate my loop from everything else. And I've done it right over there. And then when I'm done over here, once this loop is done, I want to store the answer. Well, the answer is in R2, and I'm going to say store. Somehow my cursor is jumping around on me. I'm going to say store R2 at product. And then I'm going to come over here and I'm going to say halt. We can take all this white space out of here. Oops, my halt was already there. I didn't need it. So there's my entire program for multiplying the two numbers together. I'm going to come over here and I'm going to copy it. I'm going to go over to the simulator, which is right here. I'm going to come over here and I'm going to say assemble. And I am going to paste my code in there. Edit, paste. So there it all is, right there. Again, maybe you might feel that this is difficult to read because of all the space. I can come in here and delete some lines if you prefer. Okay. At least here it all fits on one screen. I'm going to come over here and I'm going to assemble. And again, I'm told that I'm awesome. Always a nice thing to hear in the morning. Going to load this into the simulator. Okay, so here's my code right over here. Interesting here in a halt statement. Oh, it already sets a breakpoint for me. I like that. This is kind of interesting that these labels are still here. Let me see. Yeah, that's interesting that I wonder if that's a bug of this simulator. It says here, manage labels. Oh my goodness, what does that do? No, I don't want to do this. It seems to hold on to the labels from the previous ones. Isn't that fascinating? Wild. Let's clear the registers. Okay, and what I'm going to do is I'm going to run this. Okay, so first of all, notice that initially I put the number 6 in here. Notice it's down to 0. I went 6 times 7 is 42. R2, well, 2 times 16 is 32 plus an A is 10. That's 42, so that's the right answer. And let's see if it put it into product. And we can see it's right over here at product. So that worked. So here is a program where we multiplied a bunch of numbers and we stored the result. Very cool. Okay, now we are going to do something a little different and a little more complicated. Since I stopped recording at the end of the last session and started this one, I've learned a little bit more about this simulator here that we need to know. This thing, it seems that as we load programs, it keeps the labels from the previous programs. So if you come over here and you say manage labels, now I don't want to get rid of these things that say trap. We want all of those. But for example, over here, these are labels that we created in our program. We can come over here and get rid of them. And then when we come over here, those labels no longer exist. So you should know about that. Anyway, here's what I want to do. I'm back here at my text processor. And I want to write a program that says, please enter your name. And then I'm going to type in Bill. And then I want the program to come back and say, hello, Bill. So first of all, I am making use of a lot of the traps here, and we're going to need to know what they are. I'm sitting here right now looking back in the appendix. There is a trap that's called getC. That is the same thing as saying trap hex 20. Notice that I think it's actually nicer to use these mnemonics here. Instead of saying trap 20, I see getC. The thing about getC is it reads a character but does not echo. And we're going to need to use that one. There's what's called out. That is trap hex 21, and that's going to output a character. Remember, these are characters that are all stored in R0. Here's one we're going to use. I'm going to stop writing the trap numbers because we don't even want to use this. There's one called put S. Okay, and that's going to output a string. Address starts at R0. One char per word, and I null terminated. Okay, so in other words, we have characters stored in consecutive word locations, and then there's a 0 character to terminate the string. And we're going to want to use that as well. I'm just putting these down here for reference, and we're going to write this program in pieces because we have to learn how to use a bunch of things here. So I'm going to start this thing at 3000, and I'm going to come down here and I'm going to create a label called prompt, and it's going to be a string Z, and it's going to say, please enter your name. And this should be string Z. And the first thing I want to do is I just want to print this out on the screen. We're going to do this program in pieces, and I'm going to come over here and I'm going to say, well, that's the end of my program. And basically what I need to do is I need to get the address, this address, into R0, okay, because I want to use this trap right over here, puts. So I'm going to come over here and I am going to say LEA R0 prompt, and then I'm going to say puts, and then I'm going to say halt. And that's all this program is for the moment. Okay, so I'm going to come over here and I'm going to copy this program. I'm going to come over here. I am going to go into assemble and I'm going to paste this code. And there it is. It's a little messy, so let's line things up. And I'm going to say assemble. And it says, hey, awesome. I'm going to load it into the simulator. Okay, so over here at 3000, I'm loading R0 with prompt, puts, halt, and over here is my string Z. This is your please enter your name, and if we keep going down, we're going to see eventually it is null terminated. There it is, right there, null terminated. So I'm going to go back up to 3000. Okay, that's where the program's going to start. I'm going to come over here, I'm going to clear the output, clear the input buffer. I'm going to come over here, and the PC is set for 3000. I'm going to come over here and just put a breakpoint right at the halt instruction. And I'm going to go ahead and run it, and look at what happened. It came over here and it said, please enter your name. So that's really cool. So far, so good. Now, I want you to notice a couple of things over here. When I come down here, it's telling me that new line is entered as a 0A. And let's just hold on to that information a little bit. So far, we have this thing called prompt where it says enter your name. And I'm going to come over here and I'm going to put something in here. I'm going to say name. I'm going to make it a block word 20. So I'm allocating over here. Okay, this is 32 spaces, and this is all, okay, the label name, 32 spaces, they're all going to be initialized to 0. I am assuming that my name is going to be a lot less than 32 characters. So I've outputted the prompt, and now what I want to do is inside of here, I'm basically going to say, I'm going to want a loop, I'm going to say read a character, and if it isn't a new line, okay, add it to name. Okay, this is just a note to myself. So the idea is that I'm going to need something, I'm going to be using register addressing to point at this. So I'm going to come over here and I'm going to do something like the following. And I'm going to say LEA, and I'm going to say R1, comma, name. So maybe I should put some comments in here. So the idea here is the following. I'm going to come over here and I've loaded R1 with the address of where this thing is going to go to. At some point down here, what I'm going to do is I'm going to say add to R1, comma, R1, 1. Okay, and then I'm going to say branch -0 positive to next char. Where next char is over here. So I think you can get the sense of what's going on over here. Over here, I'm going to say get a character. I'm going to say check for new line. Okay. If new line, skip. Okay. Otherwise, what I'm going to do is I want to move what's in R0 to memory location referenced by R1. Okay, so this is my basic loop right here. I'm going to get a character. I want to see if it's the new line character. If it is the new line character, I want to jump out of this loop. Otherwise, remember the character's been read into R0. If we come back over here to our notes way down at the bottom, we're going to be using the get C. Reads a character but is not echo. So I'm going to come right over here and I'm going to say get C. Get a character. Okay, now I've got to check for new line. Now remember looking over here that the new line is going to be an A. Now remember the way that we're going to do it is maybe what I want to do down here so instead of putting in that, I actually want to put in the negative of this because I'm going to have to read this in and subtract it. So I go ahead and I do my quick 2's complement, and I get hex FFF, and I have to look at my numbers 6. And let's see if we, okay, and I'm going to come over here and I'm going to say not this is FFF5, then I add 1 to get FFF6. Okay, so remember, get a character and it's stored in R0. Okay, so now what I need to do is I need to add R0 with this new line character, and I need to see if I get a 0 or not. So I'm going to use another register here, and I'm going to say load. I'm going to pick R5, comma, new line, and then I'm going to say add R4, comma, R5, and R0. So remember what I'm doing here now is I'm adding the character I just read in with minus the value of new line character. If there's a 0 in here, if R4 gets a 0, that means that I just read a new line character here. So I'm going to put a comment here. I'm going to say R4 equals 0. If yes, then just read new line. So I'm going to do a branch 0, okay, to, I'm going to call it output. So I'm going to get rid of this line here. So now it says move what's in R0 to memory location what's referenced by R1. So that's an STR. And I'm looking in the back of the book now. STR says that I need to specify a source register. So my source register is R0. Okay. My pointer register is R1. My offset is 0. I'm going to get rid of this line here. I'm going to add to R1, and I'm going to say branch on -0 positive to next char. So that's going to come up here. So I'm going to come over here. I have to have a label called output. I'm going to call it here. I'm not going to do any output yet because I just want to see, now I want to print the prompt and I want to see if I actually store the name someplace. So I'm going to come over here. And I'm going to go back over to my assembler, and I'm going to come over here to assemble, and I'm going to put this up here. I'm going to do an edit, paste. Let me get rid of this other stuff here. I don't need this anymore. So here is my program. It's looking a little messy here. Let me get rid of my notes. I think this will be fine. I assemble. Ooh, line number 22. Didn't like something. Expected a fill to have a fill, was wrong. New line, fill. So it doesn't like something on this. What doesn't it like? Maybe my comments are making it angry. Oh, I think I see what's going on. It doesn't like this space here. Okay. Forces me to close this up, which is really weird. Assemble. Tells me I'm awesome. I'm going to load it into the simulator. I'm going to come over here and clear everything out. PC set for 3000. And again, I'm going to come over here. I'm going to clear that breakpoint. I always put my breakpoint right down by the halt. So there's the halt. Okay. A couple of other things I want you to notice. Notice here, here's prompt. And remember, these are the ASCII things where it's going to say, please enter your name. And that takes a little while. And then here's name down at 322. And notice there's a lot of space here for zeros. And we're going to want to see what gets down there when I go ahead and run this program. So I'm going to go ahead and run it. And I've got to bring the cursor down here. And I'm going to put Bill. Now you can, something strange is going to happen. So I've just typed in a B-I-L-L. And now I'm hitting the new line. Now notice it halted. And you're going, but wait a second, I don't see Bill over here. Well, there is good reason for that, because if you look at the trap that we use, the get C, it says over here, read a single character from the keyboard. The character is not echoed. If we want to echo it, we got to do something. But what I want to know is I want to see if Bill made it into memory. So I got to come down here. And you may remember name is kind of down. And look at that. Okay, here's an ASCII 42. That is 66, which is a capital B. And there's an I. And there's an L. And there's an L over there. Okay, and then notice those zeros are still sitting over there. So far this program worked. Well, okay, so far so good. What if I want the thing to echo? Well, there is this get C. I could also, now the other thing to do would be just looking. There is a trap that's called out that writes a character. And I think that that may be what I want. So over here, I want to check. Over here, I'm doing a character. Over here, I'm checking to see if it's the new line character. If it's not, if it's the new line character, I jump down to here. So maybe it looks like right after this, what I would like to do is an out. And I think that that might echo the thing on the screen. So I'm going to come over here. First of all, let me come over here. Let me go to assemble. Let me get rid of the program that's in here. Or actually, all I need to do here now is I just need to, let's see. If yes, then just, so it says branch of Z to output. So I could come over here and I could just say out, and I'm going to assemble it. And I'm going to load it into the simulator. And notice that the breakpoint is set to the same address as before. We've added one line, so notice the halt moved down, but we still have a breakpoint set here. We're starting to learn some of the weird things about this simulator here, but now I'm going to come down here to halt, and I'm going to set a breakpoint here. I'm going to come over here, and I'm going to clear my registers. I'm going to come over here, and I'm going to clear my input buffer, clear output. Everything seems fine. Let's just come down here and get that, look at what name looks like. Okay, name's got all these zeros. I'm going to go ahead and run this and see what happens. So it says enter your name. I'm going to put the cursor down here and I'm going to type in Bill. Oh, look at that. B-I-L-L. And then I hit the carriage return. Notice there isn't a space here. So maybe what I want to do is put a space in there. Notice if I come down to name, B-I-L and L. So first of all, I want a space in there. So that's easy to fix. I'm going to come over here to assemble. And I am going to go down to here where it says please enter your name. And you see right over there, space. Very cool. Okay. Now what I need to do is I want to print out the name. Well, remember, first of all, the name, it's got B-I-L-L, and then it's got all these zeros following that. So it almost seems to me like I could use the same thing over the same bunch of code that I did over here. So if I come down here to output, what I'm going to do now is I'm going to say load effective address of R0, comma, name, and then what I am going to do, I already forgot what it is. I need to look up at the top. Puts, P-U-T-S. And let's see what that does. I'm going to load it into the simulator. Again, remember that I want to clear this. I'm going to go down a little bit. There's my halt. I'm going to set a breakpoint there. I'm going to come over there and clear the input buffer, clear output. It looks like I'm ready to go, so I'm going to say run. And I'm going to come down here. I'm going to type in B-I-L-L. And then it's echoed Bill. Okay, good. I'm not quite there yet. Let's go back here. I'm going to come over here and I'm going to have greeting, and I'm going to make that a string Z. Hello. And now what I'm going to do is instead of saying load effective address R0 name, I'm going to make it greeting. And then what I'll do is I'll come over here and I'll say load effective address R0, comma, name. And I'll put that string out again. And I'm going to assemble it. And I'm going to load it into the simulator. And again, what I need to do is get rid of this breakpoint. And it looks like I've got one here. Yes, it does. I'm going to come over here and clear everything. I am set to 3000. Let's clear all the other registers and let's run this. I'm going to come over here, B-I-L-L, and it says, hello, Bill. I'm just a little upset because I want it to come out on the next line. Okay, I can do that. Well, it seems like it's telling me over here the new line is this character 0x0a. Why don't we come over here and let's try a trick here. So somehow or other what I want to do is I could put a 0x0a over here. Okay, or I could, let's see, where else could I do it? I don't know, how about if I did this? Well, I've got new line there. Let's define next line. Like that. Okay, so there's a next line. So maybe before I do these, I want to do a next line. So I want to output a single character. So let me see how I might do that. Well, I might do an out here. I just need to get the right character into R0. So I'm going to come over here. And I'm going to say load R0, comma, next line. And then I'll do an out. And hopefully this should do it. I'm going to load it into the simulator. Come over here. I just want to make sure I've got my breakpoint set correctly. This is not my breakpoint. Clear this breakpoint. But I want to come over here, set this breakpoint, set a breakpoint here. I'm going to clear all my registers. I'm going to come over here, I'm going to clear my output, and now I'm going to run it, and it says run, and I'm going to come over here, and I'm going to type in BILL, and then look at that. It went down to the next line. Very cool. Okay, we're going to finish up this chapter and describe the assembler process in a little more detail. What I have over here, I'm back in my text editor. This is the program we just wrote before, and I have taken out the comments just to make this a little bit more compact. But what I want to do is I want to describe the assembling process to you. And most assemblers and compilers use what's called, I'm going to come over here and see if I can annotate this on the side. They use something that's called a two-pass assembler compiler. And what that means is that in pass one, we have to scan over the code twice. And in pass one, we generate what's called a symbol table. And in pass two, this is when we actually generate code. And you'll see why it has to be done this way in a second. So here's what I want you to note, that we're going to play two-pass assembler over here. And what's going to happen is I come over here and I read this line, okay, and this says, okay, I'm starting at location 3000. Now I come over here and this instruction is at location 3000, and here's the problem already. I see this thing prompt and I've never seen this thing before. So what's going to happen is I'm going to come over here and I'm going to create my symbol table for you. And I'm going to come over here and I'm going to say label, and I'm going to say address. And over here at location 3000, I have seen a label, and that label is called prompt. And I'm going to come over here, and at this point, I have no idea what prompt is. So I'm going to put question marks there. So that's at location 3000. And now I come over here, and here's location 3001. And now here's location 3002. And at location 3002, I've come across another label here that I just don't understand. And that is called name. So I'm going to come over here, and in my symbol table, I am going to say, all right, I've seen something called name, and I just have no idea where that is. Okay, so that was at location 3002. Now, this thing over here, here's a label, and that's associated with this line. So this is, if this is 3002, this is 3003. Right over here. So I have a label here, but I know where it is. Well, I'm going to come over there and I'm going to put it into my symbol table. And I'm going to say next char, and that's at hex 3003. So that's at 3003. Here's another one here, new line. I don't know what that is. So new line is at 3000. Well, new line I don't know, but it occurred at line 3004. This is 3005. This is 3006. Output. I don't know what that is. Okay. So I forgot where I was. 3000, 3001, 3002, 3003, 3004, 3005, 3006. Here's 3007, 3008. Here's 3009. Now here's 3010, but note that it says go to next char. Okay, well, but that's cool. I know where that is already. So that's at 3010. Here's output 3011. So I can come back over here, and 3011 would be B. Okay. Okay. Notice over here, next line. Okay, I still don't know. I come over here and I see that next line is not in here. So I've got to come over here. And I don't know that. And I've already lost my count again. 3,000, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. Here's D. Let me just put that in there. X, 3000, D. That helps me. There's a label called greeting. And again, I don't know where that is. So that's 3000D, that's 3000E, that's 3000F. It makes reference to name, but that's already in my table. 3000F, that's 3010, that's 3011. So this thing over here is hex 3012, and that's prompt. So I'm going to come over here and I can get rid of that. 3012. This is going to be 3013 as name. Hex 3013. New line is going to be 3014. Hex 3014. That's new line. Next line is 3015. Hex 3015. And then greeting would be 3016. And then I hit the end. And notice, so this is my symbol table right over here, this thing over here. Notice there are no more question marks. Everything's been filled in. And that's the way I want it. Now, there could be a couple of problems. One problem could be, is I could have some label over here, XYZ, and when I'm all done, okay, going through the entire file, this still has question marks in it. If that happens, the assembler is going to come back and yell at me, and it's going to say something like unresolved label. Okay, that's not good. You don't ever want that to happen. But now, here's the thing that's going on. Now I can make a second pass over the code over here, and now all of a sudden I can go ahead and I can start to generate code. For example, I come over here and I do this. I do LEA prompt. Okay, well, the thing is what is the value of prompt? Well, there it is. I come over to the symbol table and I look it up and I've got the value for it right there. So I know that what I need to do is put the number 3012 into R0. But the thing that you realize here is that I can go ahead now with this information and I can actually generate the code for it. Likewise over here, if I'm doing a load, okay, what the compiler or what the assembler is going to do to me, remember what I have to do is the PC is going to be on the next line, but what happens is the assembler will actually calculate the offset from the PC up to the address of where new line is, which would be this right over here. Okay, so it's a two-pass process. So here's a tricky question. Can I make it into a one-pass process? Well, the answer to that is sure, but that would only be if all of the labels occurred before I reference them. And we can see over here that that's not the case. So 2 passes.